After Rosetta, we talked about that. She wanted to know about the gravitational slingshot.
I think I probably read this too late. I'm not rock and roll enough to be up at 2 a.m. in Britain.
Oh, she's a British snowboarder. Possibly Scottish Highland. Isn't it? I've been to Scotland and I was in love with Scottish everything.
But after Rosetta this week, how about explaining gravitational slingshot? I never really got it until recently.
So recently, couldn't fathom how the effects of gravity didn't cancel out upon entering and leaving the planet's influence.
Okay, so it looks like your question is something like, why does the rocket come in towards the planet, gain speed, and then as it leaves from the planet, lose that speed again? So how does gravitational slingshotting work?
Can I stop here and answer that part? She cannot fathom how the effects of gravity didn't cancel out upon entering and leaving a planet's influence. It's true, if the planet is stationary, then the effect of gravity cancels out when you enter and get out of this influence.
This is Mars and this is Earth over here. And the satellite goes around Mars and comes back, and both are exactly the same. You're correct, with no velocity between them. And it would come back, and the momentum would be conserved, and the satellite would come back at exactly the same velocity it left with. But this isn't the case.
But in slingshot, planet's motion changes before and after the rocket or satellite enters this region of influence. Point is, before and after, planet's motion changes. That's why that change of the planet's motion leaves something between the motion, original motion of the satellite and the final motion of the satellite. That difference is the effect of slingshot. Okay, let me continue.
I think I now understand it to do with relative velocities, and presumably, if the spacecraft gains momentum, the planet must lose some.
That's actually more or less correct.
And she wants a drunk explanation.
This one's for you.
Oh, man.
Okay. But the idea is, again, to think of it as in terms of a collision. So you have a large planet colliding with a very small spacecraft. Now, they actually don't touch each other. It's basically a collision via the gravitational interaction. So you can think of it kind of as scattering, where basically the big planet comes in, much like this beer, very tasty, and then the rocket or the satellite comes in and essentially has a gravitational interaction which essentially scatters it back. It's a collision process, and in the process, a large amount of momentum is transferred to the satellite. Can I do the equations now?
And the better way to think of it is like a collision between the rocket and the planet. And when the large mass of the planet interacts with the small mass of the rocket, the momentum that the planet has imparts some momentum to the rocket and sends it out faster than it came in.
Planet big, spaceship small.
Therefore, slingshot?
Slingshot. This is going to be our physical demonstration of your question here.
Question. We have a question. We all got questions. Now is the time to get your questions. I believe the word is answered. Your questions answered.
So, Dan, I wasn't paying attention. What did you say? Was that?
Where am I? How did I get here? Am I gonna ever have kids one day? Son, yes, you will. Your questions answered. these binders and heaps of data and sheets. Can I pass this test? My man, you are ready. Yes, you can. Your questions answered. Man, I spent hours and hours looking in the mirror. Do I look good?